start the session now? Yeah, we should wait for few minutes. Sure. Okay. Thank you, Celeste. So today we have to discuss about the artificial neural network for data classification based on your on data. So this is basically we have to discuss today about the uh, artificial neural network ANN. So artificial neural network is nothing but implementation of human like mind in the computational field. So in the neuron, if we say about the neural in the ANN, so ANN having various steps. ANN basically it is a implementation, computational implementation of the human brain, and how the human brain basically accept the information, train itself, and then go for its classification. That's we need to uh, discuss here. That we need to know about here. So NN is not a new thing. And we already you might have seen the some concept of the ANN in your uh, in your MC in your artificial intelligence and the machine learning book. So the NN basically NN is a implementation of the human brain into the computational field. So the first stage of the NN, the first stage of NN is your node. So whatever the exams we have in our mind, or the neurons, or you may say about the neurons. So basically, what is happening if we talk about the ANN? So in the case of the artificial intelligence, we have a various neurons, and these basically neurons, if we compare with the human mind, so these are the neurons, and these neurons are holding some value, any kind of the value, like just like your data types. So we are basically holding some value here. So it may be a positive, negative, anything that doesn't matter. So basically, neurons are holding some information, and this information need to be processed. So in the human mind, it is called a neuron, whereas in the case of the artificial intelligence, it is basically known as the nodes. So neuron and the nodes are both represent same thing, where the neurons basically uh, live cell in the human mind, which basically hold some basic information. Similarly, in the computational field, in the artificial neural network, neuron is known as the node, and this node basically holds some value. So this is the first stage of the ANN, artificial intelligence network. The second stage of this ANN is to need to process the information. So suppose that two nodes are there that need to be processed, and then we come to the some kind of the output. So the one neuron having some value 2, the another neurons may having the some value 3, and what we need to do, we need to provide some weight on this one. So weight on this one, and finally we are getting the output. So just like that, what is the weight here? What do you mean by weight? So the simple thing is that whenever you are learning at a first instance, whenever you are learning new thing at the first instance, so that having the less weightage. Less weightage means uh, you are not getting too much information. Understanding the concept in the first go. So you need to start with a very low weight, and later on we will increase the weight, so that our overall result will be uh, more fruitful here. So the thing is that if you need to calculate the y, we have to perform, suppose that the x1 is the weight here and the x2 is the weight here. So we have to perform some operation like x1 dot w1, and this weight always varies between the 0 to 1, where 0 is the least weight and the 1 is the highest weight. So we need to start with some random value of the weight, the n on the both of this function, and we need to calculate the x1 dot w1 and the x2 dot w2, and we need to add some kind of the bias value here, and this need to be calculated. This is the basic concept of the neural network. So thing is that we have a nodes. We may have given the nodes, and these nodes having, so these nodes having some information. These nodes need to be processed, and after processing, so it may be processed. So these nodes are giving the input, and this is being processed, and depend upon that what kind of the information or what kind of the machine learning algorithm we implement. We may have a various layers here. Various layers means each layer performing some kind of the basic information, some kind of the mathematics is being performed on the information gained by the neuron. So we may have a multiple number of the steps. It entirely depend upon which kind of the application we are basically executing, and finally we are getting the output. So the first important portion of the artificial neural network is your neurons, and then we have a layers. Layers, it may be any number of the layers, but at least 0 layers, and there may be a number of the layers may be here. And then we have to need to find out the connections and some kind of the activation function. So this is like a activation function that we need to see here, and with the help of this activation function, so based on this, basically we perform uh, some kind of the artificial intelligence uh, thing here. So here basically, so in order to know more about this one, artificial neural network. So basically, you need to understand about the human mind, and how the human mind basically capture the information, how the human mind basically process the information, and how gradually it basically fix its information permanently in the mind. That need to be seen here. So weight we have seen here. Weight is that whenever you are learning new thing at a first time, so there may be a less weightage. Less weightage means uh, weight should be very less, because the first times you are learning something, so you cannot get the entire information. You may not have that much information to take some certain decision. So you need to start with the weight, and gradually we need to increase the weight value. So suppose that we have started with a point 0.2, or less a 0.15, decimal 0.15. We, and in the beginning stage we may take the weight like that, and based on that we may calculate the y, that is the output, and then we readjust the weight. We may increase the weight, suppose that 2.0, sorry, 0.2, or the 0.2.2, or 0.25, whatever you need to readjust the weight. And gradually, after few iteration, we are getting the perfect y, which is not going to be changed very rapidly. So suppose that it might be possible that in the beginning you are taking the weight as a 0.15. Later on, so 0.15 you are getting the weight 0.15, and you are getting the some output like 10. So you readjusted the weight. So you have readjusted the weight. Maybe the next time you have taken the weight like 0.20. In the first instance, we have taken 0.15. Now we are taking the 0.20, and then we calculate the y, and suppose that now we are getting the y equal to 20. So in the first iteration we got the 10. In the second iteration we are getting the 20, and now with the same fraction we increasing the next weight. So suppose that we are increasing the next weight to 0.25, 0.25, and now again we calculate the y, and suppose that this time you are getting the information, if you are getting the output y like 100. So in the first iteration you get the 10, in the second iteration you got the 20, and in the third iteration you are getting the 100. So a large gap is going to be. So it is not a continuous information. So that we need to readjust this one, and in order to readjust this one we need to go for the sigmoid function. So these are the some basic of the artificial intelligence. I'm not going to discuss in more about here. So thing is that artificial intelligence basically, in each iteration it basically provides some kind of the weight, and thereafter we calculate the loss and the accuracy, and thereafter we basically get the our output y. So let me show you the neural network on the iris data itself, the code for the neural network on the iris data, so that you may have a good idea about this one, because in the since last few days we are discussing with the iris data. So you have a clear idea about the iris data, and you may have a better understanding with this concept. So let me share the Google Colab screen here, so that you may see the code. So now Google Colab. So let me show you the code, and then you may get the, you may understand what the data classification using the artificial intelligence here. So here we need to take a package that is the TensorFlow. That TensorFlow having already inbuilt artificial neural network uh, model, and just by the TensorFlow and the Keras, we may get the implementation of the ANN. So, and we performing the in this classification using the iris data itself. So as we need to go for the numerical computation, we are taking the numpy and the pandas, and thereafter we are taking the data sets. So we are loading the iris data. The same thing we have discussed in the last few days. So training, splitting, then we take the StandardScaler label binarizer to label and the classification report and the accuracy we need to take. And we are now performing, we are taking the TensorFlow, and this TensorFlow having the Keras model, which basically sequential, dense, and the categorical. In three categories, artificial intelligence means three layers it is performing. We are getting here the ANN example with the three layers here. In the first layer, we basically perform the sequential, then we dense, and then the categorical. And based on that, it categorize the, based on that it basically categorize that the new data will place in which particular category. We already have seen the category like on the iris data like setosa, versicolor, and germanica. So in the first step it accept the information, do some kind of the analysis here. Some kind of the analysis means we basically do some kind of the, we use some kind of the activation function, and then whatever the activation function, we are getting the output. Based on that we perform the categorical data in category of the data we are predicting this one. So in the first stage, we had loaded the data, and we are plotting the data, iris data on the X and the Y. And now why two categorical y. So we are getting, so the this y basically hold whatever our target. Accordingly a category is going to be decided. So the target is that we have a three classes here only in the setosa, versicolor and the Germanica classes we may have here. We have seen in the last previous lecture. So now can be categorized. So by this particular thing. Then split the data. So we have splitting the data here, and the 20% of the data has been taken as a training data set, and with the random state 42 number of random data. So 20% of data is being selected on which we need to perform the Mm, we need to perform the training data. This can be taken as a training data set, and then we perform the this ANA, and thereafter from the rest data we will take the uh, we will check about the prediction, how much accuracy of our algorithm is that. So we have splitted the data, and then the standard scalar we have seen, and then we have to go for the fitness function. Fitness function basically check that in which category the this data will fall. So now we have to build the NN model. So in the first stage we perform the sequential, and we are taking the activation function ReLU here. ReLU basically performing the sigmoid function. If you have an idea about the sigmoid numerical calculation, then you may easily understand that the ReLU basically we are basically using here, and we train the shape and then perform the activation here. Thereafter, compile the model. So compiling the model with the categorical copy and getting the accuracy. Then we have to perform the fitness function, and that is the training of the model. And then we evaluate the model by the accuracy, by checking the accuracy, how much accurate our data is. So accuracy is being here, and based on that accuracy, we basically perform the prediction here. And finally, the classification report is going to be created. So this is the simple. So here you can see that just by the just by this particular model, we are getting the NN. So NN model is already inbuilt, and inbuilt function in the Python manual calculation about each and every layer. So each and every layers will be given. You just need to import the ANN library, ANN package in your program, and you need to pass the data, and the rest of the mathematical calculation will be taken care by the Python program. So let us compile this program and let us see what the output is coming here. So the program is being compiled, and depend upon the internet connectivity and the other factors, it may take few minutes. Now our program has compiled. Now it is preparing. Now it is preparing to display the output of the program. So let's create. And so it will take up. So now you can see we are getting the output. So you can see here that so let me start with the epoch 1. So you can see, so 12 iteration here we have performed, and you can see here that how much accuracy we are getting here, how much accuracy we are getting here. So we are getting the accuracy now 100% accuracy, and this is your precision matrix we have seen. So by this way you can understand that we are getting this much loss, but we are getting the, so we have started with the accuracy 0.5, and that accuracy is being gradually improved. And so in the beginning you can see here that in the beginning we have a very less accuracy, because in the first go, if you compare this ANN model with the human mind, so in the first go, the 50% of the informations 52%, 55% of the information are being captured by your neurons. Whereas, so in the second iteration, uh, gradually it improve itself, the human mind improve itself, the artificial intelligence improve itself, and now in the last we are getting all the information from the so whenever you are in the first go, you cannot understand everything in the first go. So after few times, again you are reading, again you are reading the same chapter. So 50% knowledge definitely you may have in your mind. After that you may repeat, you may study for the 2 or 3 times. So gradually you will see that the your mind is now that information is already available. So the thing is like that way. So you need just like that in a life we are telling about that make a practice. So practice means basically we are basically iterating the procedure, the same procedure once again. So that thing we have seen here. So this is all about your artificial intelligence. Let me share the code in your chat box. I request everyone to go through the codes and try to execute the code. So I'm just putting the code. So I'm just putting the code. You may go through the code and try to execute the code by yourself so that you may have some better understanding about this artificial neural network. And thereafter, we need to understand about uh, the same thing using the fast forward neural network. So, yes, everyone, so just go to the code available in the chat box. Try to execute the code by yourself so that we have some better idea about it, what is going on here. So the code are being copied. So entire code is now available in the chat box. You may copy the code from the chat box and try to execute and understand the code. So this is all about your artificial neural network. So please make a practice here and try to do by yourself. Later on, we will see about the second the second problem given in this particular session. So it's now your turn. You may please try by yourself, and if you are getting any issue, then please let me know. And after 20 minutes, we are going to discuss about the second uh, question given for the particular session. That is, we need to implement the same thing in the fast forward neural network. FFN. So first, you try with the ANA, then we will see about the FNA. Having any issue, please let me know. The entire code is already given. The entire code is already given in your chat box. Please let me know if you are getting any issue in compilation so that we may discuss here. After 10 minutes, I'll start the session for the fast forward neural network. We have another we have another question. We need to see the implementation of the two programs in the particular session. So we will see about uh, the implementation of the feed forward neural network just after the 10 minutes. Within these 10 minutes, you may please uh, do the code I have shared. So please do by yourself. I'm here. If you're getting any issue, please let me know. Okay, so once again, welcome back. Now, let me share the screen so that you may have some better idea about it, what we are going to discuss here. So just right now, we have discussed about the artificial neural network here, and we have seen that how the artificial neural network basically predicts something, and how this ANN basically perform a mimicry of the human mind. So, so in the case of the artificial neural network, we have seen that we have a some neuron, we have a some neuron, and that neuron having some value, and this neuron have every neuron having some value, like x1, x2 are the value. Some informations are available with the neurons, and we have a some weight, and we need to calculate the y. So this is the situation of the ANN, artificial neural network. Now, here in the here we have discussed the implementation of the ANN for the data classification, and we have chosen the data set of our own choice, and so we have taken the iris data set for the implementation of the artificial neural network. Now, the problem we have given, we need to implement the feed forward neural network on the given data set for the data classification, and again we need to choose the data set by our own self. So now we need to discuss about the feed forward neural network, FNNN. So, so we already have seen about the ANN. We already have seen about the ANN, and now we need to proceed towards the FNN. So, in the case of the ANN, we have seen that we have a neurons, and the neuron having some information, some weight, and some bias value we have given, and based on this one we need to perform the some calculation, and after that if we are not we are not achieving the accuracy, we may adjust the weight, and we need to find out the particular weight. We need to adjust the weight, and we again need to calculate the same thing in order to find out the y, and this step is being repeated until we are not getting the satisfactory accuracy. So that is the scenario we have seen with the alien. Now we have another one, that is the feed forward neural network, and in the case of the feed forward neural network, we are basically implementing the ANN itself. So now the feed forward neural network is an advanced version of the ANN, where you can see that these are the neurons. All these blue plus bubbles are the neurons. ANN, ANN. These are the ANN. So here, in the case of the fast forward networks, we have we have a some input, we have a some input layer, and we have a some output layer. So these are the two layers, the input layers, and we have a output layers, and the input layers send their information to the ANN. These each box is a ANN, and based on, so there might be a lot of neurons like this way, and so in the first layer we have an input, in the last layer we have an output, and within this one and three layers we may have so many layers of the ANN here. So whatever the NN we have discussed just right now, that is now being work as an internal part of the fast feed forward neural network. So these NS perform their information, their calculation, and these pass this information to the layer of the NN, and this may be a multiple layers of the NN. It may be a 4, 5, 10, 100, any number of the event here, and then we are finally getting the output y. So y1, y1, y2, y3, and so on. So y in the output we are getting. So the working of the FNN is very similar to the ANN. Difference is that we are now using the multiple layers of the ANN here. Whereas in the case of the artificial neural network, we have seen a small part of the ANN. Now this ANN work as a major part of this feed forward neural network. For the more detail about this theoretical aspect, you may please go through the AI and the ML blog. You will find the more detail there. And now let me quickly show you the code for the this feed forward neural network. So now, so we are going to implement the feed forward neural network. Feed forward neural network. So we are going to perform here feed forward network. And in the case of the feed forward neural network, almost everything is the same. Everything is the same. So we do not need to do anything. So we do not need to change anything. Uh, the whatever the packages we have used in our previous example, that would be the same. We have to use the TensorFlow, and here Keras models, sequential, dense, and the categorical will be there, and the loading of the RDS data will be the same, the categorical, and the partitioning the data set into the training data set. These steps are the same. These steps are the same. The difference is that we just need to build the FNN model here. Earlier we have created the NNN model. Now we have to go through the FFNN model. FFNN model, and here we are just passing. So in this FNN model, so again we do the ReLU, because in the previous example we have understand the same concept using the ReLU. So again we are using the ReLU here, and we are using the almost same thing. So just a model is being changed. Otherwise, all others aspect are same. So let me compile this one. So we just have used the FFNN here, and instead of the ANN. So now you can see here that we are getting the almost same kind of the output, but the thing is that here we are getting the another aspect here. You can see here that we are getting the 97% accuracy here. So this because the FFNN use multiple number of the layers. So it basically refine the output. It basically refine the prediction. So more accurate prediction is being used by the FFNN. So FNN, this feed forward neural network, as by the name. So forward their first layer forward their feedback to the next layer forward their feedback to the next layer, and so on, and finally reach to the output layer. So it is very similar to the ANN, just we need to perform a multiple layers here, multiple layers of the ANN here. So this was the code. Now let me post the code uh, in your group, so that you may in the chat box, so that you may do the some kind of experiment here. So just I'm posting the code for the fast forward neural network, feed forward neural network. It is a very easy, not a big issue. You already have if you already have executed the ANN program, then it is not a big deal. You may easily do this one. So I request everyone to kindly go through the code and try to implement the code on the Google Colab, and let's see what you have understand here. So yes, I'm posting the code in the chat box. You please take the code from the chat box and try to implement by this one. And once again, I request everyone to kindly go through the theoretical aspect of this one, because here I am showing you the how to execute and what are the programs and the output I'm describing. But for more theoretical aspect, you please go through that one. So the entire code is now available in the chat box. You may please try this ffnm code. So I am here. You please try by yourself. If you are getting any issue, please let me know.